So Memoize in JavaScript is an optimized technique of a function that uh, store a result of a function. Then what happen is when we call that function again second time, then it will not do again that heavy calculation on that function. It will uh, uh, get that uh, calculation result from the cache. So that how we can optimize function, and that we called as a memoize in JavaScript. So let me uh, make one function that uh, do some calculation, add num, and if I for loop let I is equal to 0, I less than or equal to 10,000, I plus plus, then I can do uh, addition to total variable that will be initially 0, then I can add one by one that I value, then I can return the total after the for loop run. Then I can do console.log add num. I'm calling here this function and logging this total value here. If I do console.log time, then we can see how much it's take time for calling for the one time end. If I run this, as you can see, it's take 7.638 millisecond for running one time. So we can optimize by using memoize function for if this function is written running on second time. But if I run this function again not using memoize function, then it will run function instantly, like as you can see it take 8.168 millisecond for first time, and the second time it will take so much less time, like 0.127 millisecond. So I haven't used any memoize function, then why it's behave like this. So first time I do that, so I was confused when I see that on first time, that why this happening. uh, I haven't used any memoize function, then why it's giving result instantly. Then I found that uh, in JavaScript engine it's use JIT, just in time compilation. So uh, in just in time compilation, if it's find that function is running second time, then it will convert this code into machine code. Then uh, it will direct run on machine like C++ language. So that's why it's faster compared to running uh, this function first time. So this will in second time this function is running uh, on directly machine in machine code. That's why it's faster than running JavaScript, then compiled, then again run. So it will not again compile this function. So JavaScript is a interpreted language. It's like uh, let me give one example. Console.log 1, so 2 and 3. So it will compile this JavaScript into machine code, then it will run immediately this console.log 1, and then again this compile second line, then again this code will run uh, that compiled code, and same for this console.log 2. This will again compiled JavaScript into machine code, then it will run. So this will take take so much time. It will compile line by line, compile run, compile run, compile run. So it will take time. So JavaScript engine use just in time. So it will compiled all this function into machine code, then it will not again for this second time it will not compile this code again and again. It will use that already compiled machine code, then it will run that on the direct computer. So that's why it's not uh, taking much time than the previous run. So again, what is the difference in this just in time and Memoize? So both will give uh, instantly after the second function run. It will run instantly, but here difference is this will calculate the this this will do calculation again and again, even if this is compiled into machine code. But uh, in Memoize we direct have a result, and that we get from the cache. So in Memoize we don't calculate this again and again, but in just in time it will calculate that again and again, even if that it's machine code. So this will do calculation again and again, but in memoization we don't do calculation again and again. So let me uh, create memoize function. Function memoization, let me add memoize this, then I can do let cache, that will be object, cache. Then what can I do is I can return of anonymous function here. And I can call this function here memoize function, and in return we will get anonymous function that will be stored in memo. Let me add memo function. Then what we can do is so I have to use some value here, otherwise this will not work as expected. So I can do like number 5, then I can like I can add one parameter num here that will goes into for loop. Then I can do Memoize function that will I can add uh, arguments that will be received here. That will be num. So what I can do is, if there is a in cache there is a value for num, then you can return that value directly from cache of num. If not available there, then you can calculate that function that will be add num with a value of num, and we can store this in cache, and we can return this from cache. So here we use a closure because not anyone can uh, modify this cache from outside, so we use private variable cache here using closure. Now what we can do is let me run this function and see how much it's take time for calling first time and calling second time. So first time it takes 7.006 millisecond, and first time it's 7.6 millisecond, second time is only 0.081 millisecond. So similar like what we call, like previously we seen without Memoize function, but uh, here we don't actually do calculation. We directly get this value from cache. If I do console.log here, I can say value from cache, and I can do value of function run one time and give, and function run one time and return that value and return from cache. So let's see. So as you can see, first time is function run one time and return from cache, and in second run it's say value from cache. So every time so if I run again and again, then it will take value from cache again and again for this same value 5. If I change this value 5 to other value, then it will run again that function. It will not take value from cache if I change this 5 to other value. So here as you can see, value from cache, so it will run only one time. Then so I think this will more optimize than we are using just in time. So just in time is work for every code, every function, but this is we are doing explicitly optimizing this function. So I think this Memoize is better to more optimize the function if we have more complex calculation that takes some time, so we can store this that in this cache. So thank you.